Well, hello YouTubers, and welcome back to the Holst Mitchell channel and another episode in the woodworking series. Today we're going to be taking a look at blowers, or better yet, dust collection systems. Now, I keep running across videos where folks are putting in dust collection systems in their home shops and all that, and they're doing, for the most part, a pretty good job. But then there are little details that they're ignoring or leaving out that they're probably not aware of. So this is a video that's going to be more for the home gamer than for the pro. If the pros kind of feel like they've been left out, don't worry. There's probably a little tidbit or two that you can pick up here as well. I'll bring the camera around here. We're going to take a look at first the nomenclature of a dust collector, what all it means, what it is. There's various types of dust collectors. This, for example, is an open-faced impeller type. Then there's closed-faced. Here's a picture right here. So as you can see, the impeller is structured a whole lot different. I'll take the cover off of this and show the open face of this in a minute. But the open face is going to be the most common dust collector for the home gamer. These are the type of units that are sold by Grizzly or Harbor Freight, Jet, for example. There's no cone going up to the open face. Let me see, the Lazarus wheel, let me see here, I'll look in the archives and see if I can't find some pictures or a little bit of footage from that project. That was an open-faced impeller, but it had a cone that led up to the impeller. So. And this is just a plain old open impeller. You stick your hand in there, there's no cone in there. Like I said, this is the most common type that the home gamer is going to see because, one, they're cheap to manufacture and they're relatively low maintenance. Now, the one thing I will kind of stress here before we get going on anything else, there have been a few people like John Heiss and April Wilkerson that have modified their dust collector system from Harbor Freight with what's called the thien baffle. The thien baffle. And these things work in a setting where you're using a shop vac. They do not work with these at all. And the reason being for that, in order for them to work, you have to scale up the, and we'll take a look at that at some other point, you have to scale up the, what do you call it? In order to make those work, you have to scale up the cyclone, i.e. the point where all the dust comes together and funnels down into a catchment. And what they do with the thien baffle is they place this piece of whatever it is, you can make it out of sheet metal, you can make it out of plywood, and force the fine particulate matter to recirculate until it falls out, until it drops out along the outer periphery of the baffle. Now, that works to an extent with vacuum type setups, i.e. shop vacs with a diameter up to 2 inches. Beyond 2 inches, forget it. If you're going to use it in one of these commercially available dust collection systems, you're restricting the whole thing too much. You're going to have eternal recirculation of the material, and you're not going to get the results of clean air that you're looking for. Eventually, you're going to be forcing the air either out the discharge or through the baffle itself into the catchment. Either way, you've lost any and all efficiency that you may have had with this thing with a shop vac. So I make mention of that in my one video, to mod or not to mod, just to recap on that subject. So if you haven't seen that, by all means go back and check it out. So let me reposition the camera here, and we'll open this guy up and show you guys what's inside of here and how it works, and then we'll go through the nomenclature and all that good jazz so you guys get an understanding, so when somebody talks about a volute or a discharge or an intake, you guys know what's being talked about. So let me reposition the camera here. So this is a little hard to see because of the lighting here, but we'll start with the discharge, which is right here. This is where the air that's being pulled into the dust collector is discharged, and this whole snail thing is called a volute. Water pumps are set up in a similar way. They work in a similar fashion. They have impellers in a similar fashion that look similar, but they have a few dynamics that these air types, these air pumps, so to speak, don't have. This moves a lot of air. And here you have the intake. It's kind of hard to see with this. Yeah, I'm looking in the viewfinder here, and it's black, and the lighting in here isn't optimal. So let me see if I can rotate it around a little bit so you can kind of get the profile of it. There you go. So now you can see the intake of the thing, and of course back here's the motor. Now there are different types. Here, for example, is a picture of a belt-driven type. Now this is a direct driven type of blower or dust collector, and the cool thing about this on the back side here, and this is what you're going to see on your some of your Grizzly models as well, or your Harbor Freight, is you have a set of bolts here that you can turn this, take loose, and you can rotate this around every looks like 45 degrees, depending on where your discharge is going. If your discharge is going straight up or straight across or straight down, you can aim that discharge. You can rotate this on the frame and work with it that way, so you're not having to do all kinds of funky acrobatics with the base of the machine. You can just turn it and do whatever you need to do. So let me open up the face of this here. So got this thing loosened up, and this was sealed with a piece of weather stripping, so I'm going to have to replace that seal at some point in time. So when you open up your Grizzly or Home Depot or Jet or Harbor Freight unit, just remember out here you're going to have a good seal, because this is important. This is the vacuum side of the machine, and so you're going to have to make sure that you're not drawing air from all other places where you really don't want it coming in. So you make sure that you get this thing sealed up. You can use silicone or whatever. Just make sure that if you put your bead on this, to put a thin layer of oil on the back side of this, so that if you have to ever open it up again, that you don't glue the thing, glue both components together with the silicone in order to, and then get a good seal. You'll still get a good seal if you put a little oil or grease on the back side of this, and then you run your bead on here and let it set for, I don't know, 10 minutes or so, 15, just to get enough of a little dry film on it to where it doesn't stick or bond with this part of the machine. So that way, if you ever have to get back into it, you're not forcing this apart and bending something in order to get it apart, because on those cheaper units, this plate is usually only millimeter or 0.08 millimeter sheet metal, and so it bends real easy and it deforms real easy, and it's hard to get it to seal right. And then of course once you tighten these screws down, then it doesn't want to seal right either. So you got to find a nice little balance there. But anyway, back to the subject in hand. Here's our impeller, and you can probably take this unit and switch it around, but just keep in mind your impeller always turns. You'll have an arrow down here, for example, and that shows the direction of the airflow, and that means your impeller is going to have to turn this way in order to eject the sawdust that you're collecting, or the chips you're collecting, and the air that you're pulling in through here. So let me see if I can get this off of here real quick. One thing I'll mention before I slap this thing back together, this volute here is made out of aluminum or some kind of magnesium alloy. It's fairly light. I'm thinking it's cast aluminum. And the screws that are holding this in, these are just regular old M8 screws, hex head, and they are galvanized. So the one problem that I was having, and this is the reason this screw didn't come out very well, is there was a galvanic reaction between the zinc of this, of the bolt, and the aluminum of the housing. So one of the things you got to do is put a little bit of copper paste onto these bolts before you run them in. Otherwise, you're going to run into that same problem again, where galvanic reaction will cause the bolt to seize. So that's always a problem. And because these things do load up with static discharge or static electricity, that again accelerates the galvanic reaction. So you got to make sure that you mitigate for some of these things going in. So let me slap this guy back together real quick. So the next topic on this video, we're going to talk a little bit about ductwork. Now, for the home gamers, usually ductwork out of metal like this right here tends to be a little bit on the cost prohibitive side. The advantage that you have with this stuff, now let me follow that up with a caveat here before I really get into it. You need to ground all your ductwork. You'll have a static electric load, or you get a static electric charge building up as dust or dust-laden air passes through your ductwork. This is pretty well normal. We experience this a lot working under the Chinook helicopter or the Vertol in forest fire areas, where there was a lot of dust being kicked up by the rotor blades, and then the bird was getting loaded up statically. Incredibly, it built up an incredible static charge, and when you touched a choker to the hook, or if you grab the hook without touching the choker to it, you'd get zapped and get knocked on your duff, and that was always a source for quite a bit of entertainment on the logging crew when that would happen. So when the hook came in and you had a choker in your hand, you made sure you touched the hook with a choker before you grabbed that hook. Now. Again, you get a static, you get a static charge building up in your pipe. You'll get this in the flex tube too. Now, if you noticed dust sticking to the outside of your flex tube, that means you're getting a static charge building up, and you need to, let that go somewhere. And what you need to do, especially with with plastic, you need to have a ground. So if your ductwork is made out of the ABS, which ABS is fine, it works great in a home shop. Most guys will never abrade through the elbows. That's the one weak link in any system in ductwork is the elbows. Because the material going into the corner, into the curve, it has a tendency to abrade the outside of it, and it eventually wears through. Most home gamers will probably never wear out an elbow in their shop, although guys that are doing it, a lot or semi-commercially will eventually wear those out. So you just, if you're aware of that, construct your system to where you can exchange the corners, the elbows with relative ease, as opposed to gluing them in tightly so that when you have to go back and make a repair, you're kind of up against the wall and have to scrap a goodly portion of your ductwork. Because like this said, the metal stuff is just too cost prohibitive for most guys. So the ABS is usually a very cost effective alternative. But again, wrap a coil of bare copper wire around the pipe and attach it to the machine, because the machine is grounded, or the blower is grounded. You can also go as far as to install a ground where you ground the whole system to it. I've seen that done, works quite well. But in most cases, just grounding it to the machine itself is plenty, because you do have a ground built into the machine. There is a case ground in the plug, and so that pretty much takes care of all your grounding needs. Now, most of you will be attaching your machinery with this type of flex hose. We use it here in the plant also quite a bit, and I'll bring the camera around here and show you this stuff up close and what you need to do with this. This stuff works again quite well, and if you see static building up, the following tip is what you're going to have to do. So here we have our flex tube, and as you notice, there's a metal spiral in here, and when you cut it, of course, sometimes this kind of thing happens. This occurs. So how do you ground this? Well, it's real simple. When you go in here and just scrape off a little bit of the covering on this wire to where you get it bare on both ends to where it attaches to the machine, i.e. your table saw, your bandsaw, what have you, and the blower. Just scratch it off a little bit, and you can get a good ground that way. And then just make sure that your hose clamp is a little further up the neck so that you still have good ground, or that your hose clamp covers that part where you've scraped off the insulation here, because this eventually will wear through. But if it's not exposed, if it's just on the flange here of the intake or the discharge of the machine that you've attached it to, that pretty much takes care of it being exposed to any abrasive action that the wood chips may provide. So yeah, this is what you have. Now you have the same thing in your vacuum hoses. You have, the metal coil in there. So if you have a vacuum hose that you're attaching, if you're attaching your shop vac, you want to try and make sure that you ground that, because you will see that static buildup in your vacuum hose, and get the same effect where you get you can get zapped pretty good by touching this stuff when it's loading up. Well, YouTubers, I hope that answers a few questions you have about dust collection in the shop. Now, granted, there's a million ways you can install it. The one thing that I did forget to mention earlier is necking up and necking down. I did mention that if you install a larger intake or larger tube going to the intake, you're going to have a slowdown in the tube. You'll reduce the velocity that you need in order to move chips through the system. Now, if you reduce it, say this is a 140 millimeter intake. If I were to put a 120 millimeter intake on there, you're actually increasing the velocity. You'll have some cavitation issues, which then in turn manifest themselves in increased noise. And then also the RPMs on the blower will increase. It's not because you're creating a heavier load, it's because you're actually creating less of a load. The impeller is designed to turn at a certain RPM and run under a certain load. So if you'll experience this with your vacuum cleaner when you hit something solid and it plugs the tube and then the motor revs up. That's because the impeller is running essentially in a vacuum, and it allows the motor to turn at a higher RPM. As soon as you take it off, then there's a load back on the motor, and the RPMs drop back down to where they need to be, and that's the reason for that. So if you can avoid it, you want to maintain, if you're necking it down, like for multiple outlets, like for right here. You want to make sure that you're still covering the same cross section. When you double a pipe size, say if you go from 4 to 8, you're increasing the cross section the cross section of the pipe by approximately a factor of 4. So in order to get the cross section, you need to take radius squared times pi. So if you've got a 100 millimeter, let's see, we'll put it up right here. I don't have this stuff all in my head, and trying to figure it out on the fly is kind of tricky. So here's the cross section for a 100 millimeter diameter pipe, i.e. 4 inch, and here's one for 8 inch, i.e. 200 millimeter pipe. So as you can see, there's quite a difference in cross section, and that in turn dictates the amount of velocity that you have to have for the air to carry the chips that you're creating through the pipe. If you're below a certain velocity, so if you're opening up your intake or your pipe, and you create, with the smaller intake, you're slowing down that whole thing to the point where you may not get the suction that you need in order to make your machine work right. Now this is particularly important in planers, because if you have chip recirculation in the cutter head, you have to have enough suction on that cutter head to evacuate the chips in order to prevent that. Otherwise, with the chip recirculation, you get a kind of a funky looking pattern. It looks like your board has measles, and so you want to avoid that at all costs, and that means you've got to maintain a certain velocity, air velocity around that head, that cutter head, in order to evacuate those chips. If you have, say, a 4-inch pipe that attaches to your planer, if you're running a small planer, it's okay to run a bigger pipe to a smaller outlet on the machine, but not the other way around. That way you're still moving the required amount. You can move more air through the smaller machine than safely, or it's better to run more air through the machine, through the smaller machine, than it is less air through a larger machine. So it doesn't really make sense at first, but if you stop and think about it, if you're moving more amounts of air, that carries off those chips a whole lot faster, and makes for a better cut picture in your finished product. And the same thing with sanders. If you don't have the air flow that you need, you'll start breaking bands. If you have a belt sander, those belts will break. You'll get buildup of dust, fine dust on the surface of your board, and you'll also see waviness in there. You'll see, as you're looking over across, if you're looking at a low angle light, you'll see dents or divots. You'll see bumps. It just depends on where the pile of chips slipped underneath the belt. And so you got to have adequate air movement. You have to have a minimum amount of air movement. There is no such thing as a maximum amount. I mean, at the worst, if you have too much suction, you're going to collapse the hose. If you don't have enough, then of course your product's going to look like dog shit. Well, YouTubers, that's a wrap for this episode of the woodworking series and the ins and outs of blowers. I hope you were able to glean a little something out of this. It's excuse me. If you have any thoughts, comments, critiques, or questions, by all means put them in the comments section below. This subject is pretty deep. There's a lot of material that you can cover here. The math gets quite complex, as you just saw with some of the formulas that I threw up there on the screen for you, showing the diameter of, or the cross-section of the pipe. So keep that in mind when you're putting your system together. There are charts available. I'll try and find them and and link to them in the comments or in the description below, so that you kind of get an idea of what you got to have. For most of us, they really don't mean much. You know, you're just looking at chip evacuation, the best, the best of your ability. Just keep in mind, you don't want to go from a 4-inch intake and go to a 6-inch pipe. If you're gonna do any kind of differentiation, always neck down. So that way you have enough velocity, air velocity in the tube to where you're not creating, plugs. And then also, if you have to go through, say, 4-inch all the way to your planer, but don't neck it down, keep it at 4-inch. That way you'll guaranteed not to get too much chip recirculation in your cut pattern. So with that, thanks for stopping by. Hope you were able to get a little something out of it. And we'll see you guys all again soon.